Hey everybody, going live. I think we're almost live everywhere. Doing another coding challenge tonight. I'm gonna give a couple seconds, couple minutes for people to jump in. But thank you for jumping in if you have already. Like I said, we're doing another coding challenge. This time it's called Contains Duplicate. It's an easy problem on Leetcode.com. And I'm gonna hop into it pretty shortly here. It's gonna give a few minutes for everything to connect and everybody get online, and then I'll hop right into it. So thank you for joining if you have. And yeah, I haven't been on in a while, so it's time to do another coding challenge. And from here, I'm gonna hop right into it. So tonight, I'm doing a coding challenge called Contains Duplicate from Leetcode.com. It's an easy problem as far as the difficulty on Leetcode.com. Whether it's easy or not is up to the doer, I guess. But anyway, let's jump right into it. So I'm gonna read the problem description. Given an integer array nums, return true if any value appears at least twice in the array. Otherwise, return false if every element is distinct in the array. So they give an example here of array called nums with 1, 2, 3, and 1. So the output is true because there's duplicates. There's 1 and 1, so there's a duplicate in this array. In this example, there are no duplicates, 1, 2, 3, and 4, so the output should be false. And in this one, of course, there are duplicates, like even the first 3 are duplicates, so the output should be true. There's some constraints here where the length of the array is between 1 and 10 to the 5th power, and then the actual value in each of these is between negative, so it could be negative numbers to 10 to the 9th power or positive numbers to 10 to the 9th power. So how I like to handle these problems generally, if you watch me do these before, is I like to kind of talk through the solutions in my head and then try to see how I can convert my solution that I've thought of to code using some data structure or algorithms that I am familiar with. And so when I first look at this problem, first thing that comes to mind is like I need to be able to find these duplicates in the array. So what are some of the things I can do? The first thing I'm thinking is that I know I'm gonna have to loop through these and do some sort of conditional check to say, is this equal to this? Is this equal to this? Is this equal to this? And yes, this first one is equal to this last one, 1. And so what I could do is like I could loop through this array, and at each interval, I could loop through the rest of the array and figure out if there's anything that equals to it. Anything equals to each other, then that means I have a duplicate and I should return true. If not, if every element is distinct, I should return false. So that's the first thing that comes to mind. But when I think about that, I'm going to be looping through once, and then I'm going to be looping through for every single item. I'm going to have to loop through again to check the other items. So like, let's say I loop through this and I get at 1, and I have to loop for 1. I have to say, is 1 equal to 2? Is 1 equal to 3? Is 1 equal to 1? Yes. And if this wasn't 1, if this was 4, just use this as an example. 1, like none of these are equal, so I would start looping at this one and check if 2 is equal to 1, 3 equal to 1, 4 equal to 1, and I would say no. Then I would go to 2, and I would say, is 1 equal to 2? I would skip 2. I would say, is 3 equal to 2? Is 4 equal to 2? And I would say no. And I would go to 3, and I would say, is 1? So I would basically be doing like a loop for every item in the first loop, which would give me n squared time complexity. That's not very good for this type of problem. Like some people are mentioning here. Some people are mentioning some better solutions, so I appreciate it. But yeah, so the first thing that comes to mind is doing something like that. But that's not a good solution as far as time complexity is n squared. And for this type of problem, if you're in an interview setting or if you're even in a work setting, you're probably going to be asked or eventually pushed to find a better solution. So what's a better solution? And I don't know if maybe I should code out the first solution first, or maybe I should just go to the last solution. I don't know. I'm going to talk through the first solutions, and I'm going to try to code the last solution for the sake of time. The next thing I probably think of is sorting the array. So like a lot of times, like you get these, when you're trying to work through these problems, you have these like different things of solutions in your mind that you can try. And so the next thing that's coming to mind is sorting the array. Because if I sort it, so let's say I sort this array in order of numeric value from least to highest. If I sort this array, now 1 and 1 are together. So then what I could do is I could just loop through this array and just say, is the next element, is the element that I'm on as I'm looping, is it equal to the next element? And then I can easily find a duplicate. Like sort of a 2-pointer type of thing. And I could easily find a duplicate without having to do, I would only loop through the array one time. So that is a better solution, but there is cost to sorting an array. So sort an array is n log n time complexity, and then it would take another n, like if n is equal to the length of the array, it would take another n time complexity to just loop through the array even after you sorted it. So yeah, somebody said the sort will add to the time complexity for sure. So then your time complexity will be n log n, which is a lot better than n squared before. And you use no space in either of these first two solutions that I talked about, because you're not storing anything in you're not storing anything in some sort of data structure that is tied to the size of your input. So so that's a better solution. And so I think if you're in an interview setting, or even if you're coding this out and you're just trying to try things out, those first solutions it's okay to try those first solutions if you can't think of anything else. Even the n squared solution, to start there and then try to make it better later. I'm not going to code it out, those 3 solutions out, or 2 or 3 first. I'm going to just try to go to this last solution and code that out. But, it's okay to work your way up and wrap your mind around the first solutions and figure out what their time complexity is, why they are the speed that they are, and the pros and cons of both. If there are any, there's pros and cons, because like they're easier to understand, but they may just not be the most complex. So anyway, I'm about to jump over to the code because I don't want this video to be super long when I replay it. And I also don't want to keep y'all on here a long time, because this shouldn't take a very long time. But I didn't even go to the last solution. Some people have already mentioned it. So the last solution that you can do is when, a lot of times what you can think of when you're trying to do these problems is how you can, if you having issues with the time complexity, how you can utilize space to save on time complexity and optimize your solution. So as many people have mentioned, what we can use is some sort of data structure here to help us reduce the time complexity. And so what we can use is either a map or a set to store the value. As we loop through this array, we can store the values that we've already seen, and then on each iteration we can check against our data structure to say, do we already have this? Have we already seen this yet in our data structure? Have we seen this previously in the array? And because these data structures that we can use, like a map or a set, have a time complexity of big O, like constant big O1 lookup time, it is very optimized operation to go and look into that array, into that data structure, to check if you've already seen this before. And if you check that you've seen it before, then you just return true in the context of this problem. And so here, actually, a set would actually be better, because we're looking for uniqueness. We're just looking simply to see if something has ever been seen before in the set, basically. And so you can use a map too, but it would just be more optimal in this case to use a set if the language or programming language that you use actually has that concept in it. So anyway, I'm going to jump over to the code, and I'm going to try to code that out. So as I said before, my solution is to use some sort of data structure to store like the history of what I've looked through. I'm going to loop through every item, and I'm going to store it in a set if I haven't seen it before, if it's not already in my set, basically. If it's in my set already, then I know I have a duplicate. If I'm on one item and I've already stored a previous item in my set, that means there is a duplicate in this, contains duplicate, so it should be true. This function should return true. So I hope that makes sense. I know I'm going a little bit quick, but hopefully when I do the code that it will make this a little bit easier. Somebody asked how long I've been coding. It's been like 9-10 years, maybe even more than that. I'm pretty old in the game, I guess. But yeah, these problems, I haven't been doing these problems. I did them like way back in college, and then I started working and I didn't do them for like 5 years or so. And then I started doing interviews with them. I started interviewing other people with these kind of problems. And then, of course, anytime I would have to interview it, I have to use these as well. But anyway, and yeah, it comes up sometimes in your normal work, but I don't know, not often. A lot of these problems are solved in your normal work, but I'm going to jump right into this. So as I said, I'm going to start with using a set. So in JavaScript, I'm going to call this set scene, and I probably could use a const here. I'm not going to explain kind of the concepts of programming, concepts of like JavaScript and variable like levels or whatever, like let, const, and var. But that's something you could look up on your own. But this is how you basically create a set in JavaScript. And a set is it's kind of like an array, but like it's just of unique items. It's kind of like a map, but just a map of like unique items that you would add to it. And so it has different properties on it, like add something to the set. You can has function that you can use to check if the object has something in it already. And so what I want to do at this point is basically loop through my nums here. So I put the problem statement here for people to read. The input is going to be an array of numbers. And so what I can do is loop through these nums. And make sure I'm doing that right, because yeah, I is less than nums. Yeah, nums linked. Yeah. And so then I can get out this, and this is probably a wasted space just to get this out, so I might delete this later. But just for the sake of explanation, the num I'm currently on, and I'm iterating through this with an iterator called I. I starts with 0. As long as it's less than the length, then I iterate. And then I can pull out the number I'm on by just doing nums I, and I'm putting it into a variable. And so what I'm going to do here, I'm going to say if my set, which I called scene, if it has this number in it, then I know to return true, because that means that this nums contains duplicate because it's already stored in my set. And so how is it getting stored in my set is if the case that it hasn't, if it's not in scene, then I'm actually going to add the num to scene. And so it would be added if it's not in the set already. And so by doing that, now I'm adding anything unique to my set. And then if I have seen it, I just break out because I've already seen it already. And I know that means there's a duplicate in this array. And then finally, if I get out of this loop without finding anything, that means I've had to check every single thing because there's no duplicates, which you have to do in this problem, because in order to know that there's not a duplicate, you have to check every single item, potentially. To know that there is a duplicate, you don't have to check every item, but to know that there's not, you do have to check every item. So that's why the false is actually coming at the end of this contains duplicate function. So this looks good to me. If I'm in an interview setting, a lot of times some companies don't even allow you to run their code. They just want you to write it plainly with a text editor or something, and then you actually have to trace through the code manually. And then some companies do have a runner, like they use like HackerRank or something like that. And then of course, if you're doing this in real life development, then you'd probably just run it and test it out, because you don't have all the time in the world, but you have a lot more time than like 15 minutes or 20 minutes to do the problems in. So you could just run it and just test it out. But what I'm going to do simply real quick, hopefully, is I'm going to actually run through like a test version of this problem. And actually, you know what? For the sake of this video, because if I repost this, I'm going to actually just run this first. And then I'm going to go back and do that again. Now, you probably shouldn't do this in a normal setting, but in an interview setting, I mean. But I'm going to do it just for the sake of posting this video again, because they can only be 10 minutes long on TikTok. So, yeah, I got all my cases right. So if you remember my 3 cases over here, 1, 2, 3, and 1. That means it's true because it's 1 and 1 is a duplicate. 1, 2, 3, 4 is not a duplicate, so false. And then of course this has a bunch of duplicates in it, so it's true. It contains the duplicate. So these are the same 3 test cases over here. I got the expected result for each one that I did. So Leetcode puts in the first 3 test cases for you. You can add more. And then you could submit it for all of Leetcode to see where you stand within all the other users of Leetcode. So I'm going to submit this and see where I stand. I beat 66% of time complexity of all of the users, and I beat 75% of all memory of all of the other users. I think I could probably make this even faster if I take this out and just use, if I don't put a variable here, because I'm kind of wasting space right here setting up this variable. So I think I can just take this out and do that. So make sure that still runs. Yeah. And then submit it. This is kind of a Leetcode thing. I wouldn't probably do this in a real scenario, but yeah, see, it got me up to 89%. It got me up to 87% just by removing that variable that I was storing it made the code look cleaner, but it wasn't as optimal. I wouldn't really worry about that in a normal scenario, so I'm probably just wasting time really even considering it. But anyway, so yeah, that's basically how the problem works. Looks like I got it right. The time complexity of this problem, which I forgot to do, is big O. Shoot, what is the time complexity? I think it's big O of n, because I'm literally, the only thing I'm doing that's tied to the size of my input, the length of my input, the number that I have, is called it n, is I'm just looping through n times and doing basically n operations here as it pertains to the size of the input. So not counting every single thing I'm doing here, but as it pertains to the size, what is tied to the size of my input, this loop is tied to the size of my input. As far as time complexity. So as far as space complexity, at the worst case, and as is always worst case, but at worst case, at least for big O notation, at worst case, how many things would I store in this set? So now that I'm using a set, I do have some variable or data structure that is tied to the size of my input, which is nums. And nums has a length, which we're going to call n. So in this case, worst case, and what is the worst case? The worst case is if there's no duplicate. So I have to go through every single one of these and check it. That means I'm going to store every single one of these in the set. And what did we call the length of this? We called it n. So that means my worst case space complexity, is also big O of n. So what happened was, if you remember in the first solution, my time complexity, whatever. I'm just going to put space. You guys know what I'm talking about. But yeah, what happened was in my previous solutions, the time complexity was like n squared, right? And my space complexity was big O of 1 before, because I wasn't using any space. And like I said, so sometimes when you optimize, what you're able to do is use space to make up the time. And it will lower your time. It will lower your time complexity, but you're using space. And depending on your problem, depending on what you're trying to do, it makes it a lot better. And somebody said, "What's the difference?" Basically, the space complexity before in the previous solutions was 1, big O of 1, which means constant space. That means I didn't use any space that was tied to the size of my input. I just set some variables that would completely be wiped out of memory after they executed, after they lost context. But when you use like a set or something like that and you tie it to the nums, The reason this matters, and I know this may be hard to understand if you're new to these kind of problems, is what if nums was 1 billion in length? That's why these problems matter as far as time and space complexity. So if I had to store 1 million items in this set, it makes more of a difference than if I'm storing 4. Or even with time complexity, if I have 1 billion nums to loop through, then I only want to loop through those one time. I don't want to be like, I don't want n squared where it's 1 billion times 1 billion. The compute, like, it just wouldn't be able to be computed. It would time out in most scenarios, and depending on how expensive these operations are, it would make it even worse. So this is why companies ask these kind of problems, because it does have a deeper meaning. Now, do you do this stuff every day? No, but there can be times when you do run into complexity issues and resource issues where, let's say you were making a database update in the middle of this, then yeah, you do want to do less database updates. You don't want to do n squared database updates. You want to do n, or probably less, honestly, if you can. But that's why these problems matter. And somebody was saying that space complexity is big O of n. So somebody was saying it was big O of 1, or constant space complexity. Now, this operation here is constant, and that's why we use a set. So to look up whether something's in a set, that's what the power of using a set or a map is, that the operation here is constant, and so we don't lose a bunch of time doing it. And so that's what it is. But like, space complexity is based on how much you actually store in a set. And at worst case, I'm going to skip, if I have all unique values, I'm going to go into this case every time. And I'm going to actually store up to n, where n is the size of the array values inside of this set, which makes my space complexity, at worst case, big O of n. So I know I've talked a long time. I asked a bunch of questions. Somebody said, I did this in 3 lines of code. Can I send it to you? Yeah, sure, man. I'm probably going to get off of here in a second. Somebody said, can you tell me the different kind of loops? I think I'll probably do another post on that. But I appreciate y'all watching. I hope this was helpful for people. Check my account. I do these. I've done these for the last couple months. I'm going to continue doing these for the next few months. I'm on Instagram, Facebook, Twitter, Twitch, YouTube, TikTok, all of that. So you can watch the same stream everywhere. You can look at all my content, funny content, informational, coding challenges. These don't get done enough live, or not even non-live, on social media. And I feel like some companies will interview with these, and I feel like you need help with these. And even if you're not interviewing them, it's not just interviewing. Like, just understanding time complexity and space complexity is important if you're in school, especially, and even in your jobs at some points when you have to deal with problems that have not been solved yet. Now, if there's a library you can use that's doing all this stuff, that's what you use. You don't do this yourself. But it's important to know what the library is doing under the covers, or the function that you're using is doing under the covers. So with that being said, I appreciate everybody that tuned in across all the social media platforms. Let me know what you want to see next. Follow, subscribe, and all that good crap. And I'll see y'all in the next live, or next post, or next video, or whatever. Appreciate all the comments too, people. Thank you. See y'all next time.